Zeal Education Society, redefining excellence.
Students, I am Dr. Mahadev Unde, Zeal College of Engineering and Research, Pune. In a previous video lecture, we have learned the polyphase system, and that is the three-phase systems, EMF generation, their waveforms, EMF equations, and the phasor diagram. We have also learned the phase sequence, its application also. Then in this video lecture, we are going to learn some definitions and how these armature windings are connected either in star or delta. So let's start the symmetrical supply system. This is second definition, symmetrical supply system. The system is said to be symmetrical if the three-phase voltages are equal in magnitude and displaced from each other by equal angle. So the system is said to be symmetrical. Symmetrical when three-phase voltages are equal in magnitude and displaced from each other by equal angle. For example, say phi Ry equal to 400 angle 0 degree. That is 120 degree electrically apart. Then EYB equal to 400 angle minus 120 degree. EBR equal to 400 angle plus 120. So this is the symmetrical supply system. Then the next definition is, now we have generated the voltage and that is at the generating stations. We have to carry out this energy or a power to the load centers. Load centers are nothing but the cities where the electricity is utilized for the lighting and the street light, offices, for motors, agricultures and the industrial purpose. So these industrial hubs, MIDCs and the cities, these are known as the load centers. So the energy has to be carried out from the generating station to the load centers. And at the load centers, we have to connect the load. Now, these loads are said to be a balanced or unbalanced load. So, balanced load. The three-phase load is said to be balanced. The three-phase load is said to be balanced when three load impedances are equal in magnitude and are of same nature. Balance load. So Z1 equal to 8 plus J6 equal to 10 angle 36.87. Then Z2 equal to 8 plus J6 10 angle 36.87. Z3 8 plus J6 10 angle 36.87 Ohm. So all these three impedances, load impedances are equal in magnitude and all are inductive. Plus sign indicate that they are inductive. So unbalanced load. Unbalanced load. When the three phase impedances or three load impedances are not equal in magnitude and are of not same nature, then we can say it is an unbalanced load. When three phase load impedances are not equal in magnitude and are not of same nature. For example, say Z1 equal to 8 plus J6 equal to 10 angle 36.87. Z2 equal to 6 plus Z8. 6 plus Z8. Angle is 10, but this is 53.30. See, both are inductive here, magnitude are same, but these are not same, equal, because their angles are not same. Angles are not same, unbalanced. So Z3 equal to 6 minus Z8 is 10 angle minus 53.40, unbalanced. This is capacitive. First two are inductive, but their phase angles are different. Here it is capacitive. Magnitudes are same, but this is capacitive. Say that is unbalanced. That can also be represented by in terms of the currents. If the three currents, obvious three phase currents are equal in magnitude and displaced from each other by equal angle. For example, I1 equal to 10 angle displaced equal and by 120 degree. 0, I2 equal to 10 angle 120, I3 equal to 10 angle minus plus 120. They are equal in magnitudes. Now see, the load in electrical engineering, load means current flowing. When we say the motor is loaded, means it is drawing more current. When it is overloaded, means it drawing the more current than its rated value. So the load is, and in mechanical load, the load may be in kg or Newton, whereas in electrical engineering, it is considered in terms of current. Now the star connection. Now the three armature windings may be either connected in star or in delta. So let us have a star connections. This is neutral and there is this one also, and it goes to the load. Say this is load. Over here this is three-phase load, maybe star or delta connected, and this is supply system. And these are the lines. So this is R, this is Y, and this is B. So this is generator which is at the generating stations, and these are the lines which carry the electrical energy or power to the load centers. So the current flowing through the lines is known as line current, IR. So this is IY, so this is IB. And the voltage between any two lines is known as line voltage. For example, this is ERY, this is EYB, and this is EBR. So you have to go as per the phase sequence, R, Y to B. It's between R and Y, then Y and B, and then B and R. So these are the line voltages. And voltage between the any line and neutral, say phi RN, phi RN, phi YN, phi BN. These are the phase voltages. And phi RY, phi YB, phi BR are the line voltages. And IR, IY, IB, these are the line currents. Because these are the currents flowing through the lines is known as line current. And the current flowing through the phase of a load or phase of a winding, when the load is connected, the current will flow through the winding. So this will be the, say, I small r, I small y, and this is I small b. As soon as load is connected, this current will start flowing, and therefore we can say IR, IY, and IB are the phase currents. Similarly, we can connect in delta. Denoted by triangle, and this is denoted by star or Y connection. Okay, so here it is. This is also known as three-phase four-wire system. Three-phase four-wire system, because this neutral can also be used for the single-phase connections. That can be supplied the three-phase system as well as single-phase system, and that's why many times it is called as a three-phase four-wire system. But in delta connection, it is always three-phase three-wire system. This goes to three-phase load. This is R, this is Y, and this is B. Now current flowing through the lines is known as line current. Say, when the load is connected, current will start flowing, and this will be then small IR. This is IY, and say this is IB. So this IR, IY, and IB, these are the phase currents. But this will flow only when load is connected, phase currents. And I capital R, I capital Y, I capital B, these are the line currents because they are flowing through the lines. And what is this one? This is once again phi RY. Then this is phi YB. This is VBR. We have to go as per the phase sequence. Generally it is RYB. So here it is, and what is the voltage? If you connect the say voltmeter across this one, voltmeter. So this is the voltmeter. If you connect the voltmeter between, say, this is R dash, Y dash, and B dash. R dash, Y dash at this low terminals, the same voltage will be available across this R and Y. So we can say this VRY, VYB and VBR, these are also phase voltages, and these are also line voltages. They can be denoted by some other nomenclature also, but in delta connection, the line voltage equal to phase voltage. Phi line equal to phi pH. That is phi pH equal to phi L. So in this way, in this video lecture, we have seen the symmetrical supply system. The system is said to be symmetrical when three phase voltages are equal in magnitude and displaced from each other by equal angle, that is 120 degree electrically apart. We have like unbalanced load, then the unbalanced load. It can also be represented by the currents. Then the star connection, the armature winding in the alternator may be either star connected or delta connected, and when the load is connected, the current will start flowing. The current flowing through the lines is known as line currents, and voltage between any two lines is known as line voltage. The voltage across the phase of a load or between the any lines and neutral is known as phase voltages. For example, Vrm, Vym, Vbn are the phase voltages. And when the load is connected, current will start flowing through the armature windings, and that will can be denoted by capital I small r, I y, I small b. These are the phase currents. Similarly, the winding may be connected in delta, and similar quantities we can observe here also. But in delta connection, phi pH equal to phi L, and if you observe carefully in case of star connection, see this is small IR, star connection, small IR equal to capital IR, small IY equal to capital IY, small IB equal to capital IB. So what the conclusion we can make, IPH equal to IL, star connection, and phi pH equal to phi L for delta connection. Okay, we'll stop here.